Okay, thank you very much for being here, for accepting our interview. But we have four astronomy club members. Let me see. Yes, and here is my journalist right here. So again, there we go. So here we go. There she goes. So that's Mia Amador. She's our CRTV journalist.
Hi, Mia.
Hi,
Okay.
nice to meet you.
So
I'm
and
Ian Amador. I'm a journalist for Miss G's class.
Thank
it's
you all for meeting so late in the day. I know it's like dinner time for everyone, whereas for me, the afternoon is still going. So I really appreciate that.
Oh no, thank you. Thank you so much for agreeing to this interview. Thank you.
so Mia, just to clarify, so it's Dr. Anjali Tripathi, and I'm
Okay.
going to go ahead and throw it to you so you can start the the question and answer part of the interview. Then obviously we'll Miss we had included Dr. Tripathi in our wonderful strategic email, so now she knows that you're going to send it to the astronomer's going to send it back, and it is what
Yeah,
it is.
yeah. Okay.
Okay.
First of all, thank you so much for being here. Secondly, just to get the audience to know you a bit, could you tell us a bit about yourself, your occupation, and what prompted you to excel in such occupation?
Sure. So I work at NASA, which of course means that I do all things space, but I grew up here in LA. So even though I work back in LA, when I was growing up, one thing that drove me crazy, which you're lucky not to have in Florida, are earthquakes, right? When I was a kid, we couldn't live in our house for a whole year. So it wasn't a hurricane, it was an earthquake that destroyed our house. Um,
Wow.
so because of that, I wanted to become a scientist because after an earthquake, the people you see on TV who can explain what happened are the seismologists, the scientists.
Mhm.
So I went to college and said, I'll study earthquakes and then I can help people and I'll be able to predict earthquakes. But of course, as we know, you can't actually predict earthquakes the same way you can predict the weather. So that's how I went into astronomy. I thought I'll study physics to understand how everything in the universe works a little bit. And then I just saw all these pretty pictures of the stars and galaxies and the fact that in your computer, you can actually simulate what's happening in space and make it look pretty real. I thought that was so cool. And so that's how I got hooked on astronomy. But I will say I would still love to be able to solve the problem of earthquakes and other things that bother people because
Wow.
making people's lives better is definitely really rewarding.
Yeah, of course. That's a really impressive that's amazing. I mean, I'm shocked. That's great. Secondly, Miss G, she told me about you being on Jeopardy twice. Could you tell us a bit about that?
Sure. When I was a kid, there were tryouts to be on Jeopardy with your parents, and I had never been to a TV studio before, so I just wanted to try out just to see the studio, right? I wasn't doing anything cool with the media like all of you. So I went and I tried out, and they said, You'll hear from us in 6 months, and I didn't. And so I thought, okay, I'm not on TV. And then, like 7 months later, they came back and said, We'd like to have you, but just the kids. Kids with their parents don't look as good as just the kids. So I was on Jeopardy in the 90s when I was in seventh grade. And then they had a reunion show where I was in college and I got to come back. And so it's pretty stressful in person to have everyone see you answering questions right or wrong. But the hardest part about it is it's buzzing in because you can't just buzz in anytime you want. It's only when they finish reading the question, then the first person to buzz in gets right, or gets to answer. So it's a lot of video game playing would be helpful for it, and a lot of strategy, not just knowing things. So it was a fun experience. But that was the first time I was ever on TV. Little did I know that all of the rest of the times I would be on TV would also be for being a science nerd.
Wow, that's I don't know many people that have been on Jeopardy, so it's definitely going on my list. I'm gonna pass it to the Harmony Club, and then I'll come back with you some more
All
questions.
right, sounds
Thank
good.
you.
Let me just really quickly. So for moving forward, and this also for me and for the Astronomy Club, when you pass on the question, mute yourself so that we can get Dr. Tripathi's full answer, and just her answer. Because sometimes if she's the only one talking, then her picture becomes the bigger one on the screen. And then when you're gonna ask questions again, unmute yourself, and then so forth and so on. Okay.
Got
So.
it.
All right, so I'm going to present the president of the Astronomy Club, Miss Josefina Manzaneros. I'm sorry, I think it said it wrong. Manzanares. Go ahead.
Canales. Hi, I'm the president of the Astronomy Club. I actually founded it this year. and have two of my board members in here. And along with some of the members that came this past 11th, we made a couple of questions and we came up with a couple. And one of them was by the audience. What sparked your interest in the studying of exoplanets and what made you pursue the career?
Yeah, it's funny. So you all are young enough that exoplanets have existed your entire life. But when I was born, we hadn't found any exoplanets yet. And so it was really exciting when I was in college to have a professor say, "Oh, yeah, I work on something that didn't exist when I was in college." And, there are planets outside of the solar system. It's something that people have dreamed about for thousands of years. And then one day, they just started finding them. And they don't find them in just one spot, they're everywhere. And so for me, it was these things that like stars are a little hard to understand, right? Because it's this ball of gas that's big and hot, and it's nothing like we experience. But a planet, like I understand what a planet is. I understand what a planet is a lot better than a moon or a galaxy or anything else in space. And so I got really caught up in studying exoplanets because you can then imagine what it's like a little bit, but also find things that are totally different from Earth. And that's really cool to see what else is out there in the universe. It's like finding different animals that you've never seen before, and you think like, that's really pretty. Whoa, we can do that. That's cool. So that's how I got into exoplanets.
That's so cool. I'd love to like find some planets sometime. Another question was, what do you see as the next big frontier in space exploration? Which role do you think is like the most important that you play for the exoplanet, like discovery?
Oh, those are good questions. I wish I knew what the next big frontier would be because then I could go and work on it now and be with the people at the frontier. But I think one thing that we're trying to do is we're trying to find planets um, that are not only, out there orbiting a star like the sun, but ones that have signs of life or conditions for life. And it's a little bit crazy, right? Because people have talked about aliens for a long time. I love your headwear, by the way. Thank you, and the shirt, the whole thing. All of you have really good backgrounds. I like the space shuttle poster too that you have, Maya. But it's one of these things that if you think about, oh, I wonder if there are aliens, it's kind of like saying, oh, I wonder if I could, grow 10 feet tall. Right now, we don't have the technology for me to grow to twice my height. I'm pretty short. Being taller would be nice. But if we want to study aliens and life, we are actually at this place where you don't just have to say, I wonder if I can study it on the moon or on Mars. It's like, oh, there are thousands of places I could look where we've already found, and there are hundreds of billions more where we could look. So I think the frontier that we're hoping to make progress on is, actually being able to look for signs of life. Or the conditions of life. Like if we can find pollution on an exoplanet, you don't often think of pollution as something that we want to see. But actually, if you could find pollution on an exoplanet, that would be amazing because that couldn't happen naturally. It needed life to exist. And so this is the frontier of astronomy, sort of exploration. And you asked, what's the most important role that's needed? And I don't think there's one role that we need. We kind of need everybody involved in this. So I do some science, and by the way, you asked about um, how I got in this path and said that discovering exoplanets sounds fun. I just want you all to know you can all go and work on finding planets after we're done with this call. There is a website called planethunters.org, and they actually give you real telescope data and say, like, we have AI and computers doing this, but they miss things. Can you help us? And that's actually how one of my favorite planets, Planet Hunters 1b, was found, which is just people like yourselves who said, oh, I wonder if I can find a planet. So everybody can do that. But I think, you need scientists to sort of think about the research questions and analyze the data. You need engineers to actually build the telescope and make everything work. You need people to talk about what's going on and teach other people. So a lot of what I do today and what I really enjoy doing is having conversations like this, both with students in school, in college, going and talking on TV and getting people excited about it and thinking about things because I know I'm not the smartest person in the universe and I need a lot of help. And I think that's how all of us feel. So getting people inspired and involved in lots of different ways is really helpful. And I think it's really easy to think, oh, you can only be studying exoplanets and space and astronomy if you get really good grades and if you do really well in physics. And, I work with artists all the time, right? We have everything from, patches to, cleaning cloths that people are designing. And, I think that our art, we just opened an art exhibit about a month ago that I got to work with. And I worked with a perfumer and a sound engineer. So in one room, all you do is smell the smells of space and what it would be like to go to an exoplanet. So on one of them, you smell what a clean spaceship smells like. You smell what a garden on Mars would smell like. And then you can hear the sounds of it. And I think that reaches people in ways that you wouldn't otherwise. So I know I get too excited and talk too much about all the different ways to get involved, but that's just to say there are lots of ways to get involved if you're interested. Oh, and here's the art behind me. Yeah.
No, that's great. I'm personally in the art academy at my school, but
Oh,
I'm
very
also
cool.
extremely like interested, so that's why I started it.
I
Um,
appreciate that.
uh, I have another question that one of the club members asked was, what's one of the closest planets with living conditions to humans? I know that there are like a couple of them around, but I don't think that there's like ever like one that's like the closest. I don't know, I'm not sure yet.
Yeah, so when we think about planets that we know that have the conditions for life, within our own solar system, we think Mars and Venus may have had the conditions for life in the past. So those are places we really like to study nearby. So those would actually be the closest planets because, we can send rovers and they can go drill into the surface and take samples and check. And we actually just launched a mission to a moon of Jupiter. So not a planet, but it's actually looking to see if when it gets there in about 5 years, if it's going to find anything under the ice. It's this icy world with an ocean underneath. And is there any signs of life there? So these are all places where we can have a pretty good idea if there's life or signs of life. When we look out at these exoplanets, they are so far away, you can't even see them for the most part. You're just seeing how the light of the star that they go around changes. And so telling if it has the conditions for life, we're not really there yet in being able to say, yes, that has the conditions for life. So that's why I mentioned it's on this frontier of things that we can check out. But right now, we don't know of any place that has the conditions for life outside of the Earth. That said, we have found planets around stars like the sun. So, there are these stars that are a little smaller than the Earth in Alpha Centauri, right? And we have seen planets, but they're nothing like Earth. They're really big, like Jupiter. And so if you try and find planets that are small like Earth and around a star like the sun, because if you're around a really angry, active star, then you're going to have the conditions that cause auroras, all of these solar flares all the time, which are going to be really stressful and not great for life. But if you find a star that's going, or a planet that's going around a star like the sun, and the planet is just the right distance away, that it's not so close that it's hot and it's getting burnt and roasted, and not so far that it's really cold. You want to be in just the right place where water can actually still be liquid, and there's enough of an atmosphere to keep the water on the surface, because, we all love water, but it's also the thing that we know helps with life. We don't know of anything else that life needs to exist right now. So that might be kind of an unsatisfying answer that I don't know where the nearest planet with lifelike conditions are, but if one of you finds out, I would love to know.
Actually heard about the Europa moon, but I didn't know that it was so close for it to like land. That's like really exciting. That would be around the time that like my class gets out of college, and to think that by the time that I'm out of college, there might be some investigation on the moons and the ice behind it. It's like really interesting.
Yeah.
This is a personal opinion question. But do you believe that if we were to find life on this moon, we would try to keep our distance from it, or we would try to like befriend them, like in movies?
That's a really hard question. I think people often say if you look for life and if you know you did everything right and you don't get an answer, is that worse than getting an answer? And actually, whether we're all alone or whether there is other life out there, I think both are really deep, profound answers. Personally, I'm really curious, and I think if we're able to study things, we should. Of course, as with everything, we don't get to decide what the other organisms will do and how that will all work. So I think whatever we're able to study, we should and, have those interactions. And I just want to go back a second. When we talked about Europa, I might not have done a good job of explaining it. So the mission Europa Clipper that launched last week, it's actually going to go and orbit around the moon. So it's not actually going to land. Hopefully, future missions will be able to land. People have designed all kinds of amazing robots that can go and crawl under the ice upside down and stick to it and study the oceans. But we're not there yet. First, we're going to fly around it to get a sense, just like you have good satellite imagery from Google Maps or of the Earth to see what's there, to then decide what comes next. So we're not quite there for you to have a graduation present from college of like, here is the life on Europa, but soon, soon.
That's still pretty interesting to maybe have some satellite images of Europa. The next board member that I think has some questions would be Isabella. She's our historian, social media manager.
Hi. So, for you, what has been the most surprising discovery in your work of exoplanets?
Yeah, and I think it's really cool, by the way, that you are the historian of the group. I think that astronomy is one of these really rich areas, and people are always complicated, and there's always lots of stories there. And so stories are the best way to connect things. And I say that because there are probably really important discoveries, that I should mention when you ask this question, but I actually think of a pretty picture in answering this question. So one of the things that I did during my PhD was I made these really detailed computer simulations of what happens when a planet like Jupiter, really big and puffy ball of gas, is close to its star. And, the one side of the star, or the one side of the planet is always facing the star, right? It's what we call tidally locked. And it turns out that most people had studied this planet simulation in like 1D or 2D, and I was the first person to do it in 3D. And you would kind of think that if you're just getting sunburned all the time on your face, like, okay, maybe things will happen, you know, where they can actually push back because like the sun is so strong that nothing was able to sort of push out. But actually, what you find is not only is it like my hair would be sort of streaming past me if the star was facing my face, but actually everything on the front of my face was sort of going around. And so you ended up watching everything just sort of mold and morph and come off of the back. And it was having all of these rolls of gas. And so it's something that we didn't expect. I always like being surprised in science, but also it's really pretty. So if you look up pictures of simulations, or I can send some to you, you'll see that there's just like, it looks like things are oozing around the planet. And you think like, it's an atmosphere. You should stay there. You should not be oozing around to the other side. So I think that's pretty fun.
Yeah, that's so cool. Could you describe a recent discovery or project you've worked on in the field of exoplanets?
Yeah, so one of the things that we're actually working on is thinking about where are you going to find a planet like Earth? Because, right, I've told you we found almost 6,000 exoplanets as of today. And of these, it's just been sort of like looking at a bunch of stars. And when a star happens to show signs of it, you say, oh, okay, there's a planet there. And there are some stars where we've looked really hard, like especially around Alpha Centauri, Proxima Centauri, where we say you're nearby. We really want to find a planet around you because that would be closer to get to. But one of the projects that I'm working on right now is thinking about a telescope that we're going to build in about 15 years called the Habitable Worlds Observatory, right? So it's looking for habitable worlds, right, where it can find lifelike planets. Um, and the question is, where are we going to point the telescope? Because you don't have, all the time in the world to say, I'm going to point my telescope at every single star, and I'm just going to cross my fingers and hope that it works out. And so we're actually trying to find where are the conditions just right that if you assume there's an Earth-like planet, where would you actually see it? Because, right, say your planet is really close to the star, it might be so close that you're blinded by the light of the star and you can't find it. And but that's the only place where water can be liquid. So helping with the team that has come up with this list of stars, we call them sort of precursor target stars, and thinking about how can we get other people studying this and excited. So it involves not just the science side, but we actually have an app online where people can go and study them. You can read about where these stars showed up in Star Trek and like play with them in 3D maps. It's pretty fun. So it's a project that I've had a lot of fun with because we get to do all of the different parts of it, both the science and the outreach and communication.
Thank you. What role do you see exoplanet exploration playing in the future of space exploration, particularly regarding the potential discovery of life beyond Earth?
Exoplanets were not very popular when I was in college. Now they are super popular, and I think that's only going to continue. Like, if you study stars in astronomy these days, that's actually considered really boring to a lot of people. But you can imagine 100 years ago, being able to actually make measurements of a star because, like, you actually had the technology to do that was super cool. So I think exoplanet exploration is going to be this field that's probably going to be a little bit younger and a little bit more vibrant and exciting than some of the other fields in astronomy. And I think that's pretty cool. And I think that whole notion that there are so many places that we can now search for life will keep a lot of good ideas and, interesting people um, coming in. And so I think the search for life is like a huge driving force in it. But of course, there's lots of other good science that you can do anywhere. I'm very biased and think exoplanets are really cool.
Yeah. What future developments in exoplanet research are you most excited about?
Hmm. Future develop. So I will say one thing that we want our future telescope to do is actually take pictures of these planets. So have you all heard the term pale blue dot before to describe the Earth? Okay. So the reason that term came up about is when Carl Sagan was working with NASA on the Voyager mission in 1990, actually, I think it was on Valentine's Day. The spacecraft was far enough from Earth that they said, okay, we're actually going to turn it around and take a picture, right? It was like a selfie of the Earth and all the planets in the solar system. And in the selfie, the spacecraft was so far away, you couldn't see clouds and continents and oceans. All you saw was basically like a pixel, right? It was this like light blue or pale blue dot. And if I just showed you a picture today of a planet and said, like, it's a pale blue dot, you would say, that is not that interesting, right? Like, look at the art behind me. We want to see all kinds of detail. Um, but I think, the technology that we're working on today is going to allow us to get closer to this ability to actually take pictures of planets that are going to be a little bit like Earth. So already we can see planets that are really big, like Jupiter, moving around their star. And that's really cool to know they're there. But I kind of want to see that pale blue dot and take those actual pictures because I don't know what we're going to find. And there might be some surprises there. So that's one technology I'm really excited about.
Yeah. One last question for me. What's your opinion on the Vulcan planet, the hypothetical one?
Can you tell me a little bit more? Because there are two different things I think you might be referring to. So tell me a little bit more, Isabella.
I don't know much about it. I was hoping you would. I just know it's a planet that's been deemed like hypothetical.
Josephina, did you want to add something or were you just doing the Vulcan sign? Yeah, go for it.
No, I've heard that it might be related to Star Trek. I haven't watched any like science-y movies when it comes to that, but I did read.
Are
I have
you
a
are
little
you
book here that's
are you
called
referring to something called Schrodinger's galaxy, or the type of where it's
no,
two different places?
it's a hypothetical planet that was like theorized a little while ago because of the way that there was like a mathematic equation that that had a fault on it, and the people at the time thought to explain it by there being a missing planet. And so it was theorized for a while that this Vulcan planet was a thing in the solar system in
Oh,
between, I think it was Mercury and the Sun,
no,
or Mercury
the
and
Kepler belt,
Venus.
like the Planck, the Planck, the Planck.
Okay.
Yeah, yeah. Okay.
All right, so I think there are a couple of different things there that all have the name Vulcan. So let's do them just sort of from nearest to furthest. Um, so back like 115 years ago or so, almost 120 years ago, if you were in school and you saw a map of the solar system, the map of the solar system would go Sun, Mercury, Vulcan, oh sorry, Sun, Vulcan, Mercury, Venus, Earth, Mars, and so on. And it's like, wait, what? We don't talk about Vulcan. And the reason that there is no Vulcan that we talk about is actually Einstein, because Einstein's theory of relativity in 1915 said, hey, if you're really big and massive like the sun, actually all of space-time sort of has to curve around you. And so the reason that people thought there was this planet called Vulcan is because Mercury's orbit was not quite what we would expect, right? In the same way that I can tell you exactly when there's going to be an eclipse, right? And when you're going to need to put your glasses on. People could predict things really well. And with Mercury, there was something a little June was that we said, oh, something's a little bit off. I bet there's another planet there. And they looked and they found a planet. And so there were people who said, like, oh, we think we took some measurements that show that there is this planet Vulcan. But of course, when Einstein came along and said, no, no, that's just gravity, um, sure enough, it was confirmed that explained what was going on. And so it turned out that there was no planet Vulcan. So that's the first time people talked about Vulcan. In Star Trek, though, there is the place that Spock comes from. And it's purported to be on the planet 40 Eridani A. And this is actually a planet where we actually found an exoplanet there and we're really excited about it for a while. But actually, as of last year, new research suggests that that might not actually be a real exoplanet. There might be something about the star and our data that looked like a planet but aren't real. So there have been a lot of Star Trek fans who have been upset with us saying that you said there wasn't a planet there and then there wasn't one. So those are the two Vulcans. Also, can you all still hear me? Because I know that it's showing me that my internet connection is unstable, and I'm worried that I've lost you.
So we can hear you, but we can't see you. So can you hear us? Hello? When you message, let me see. We can hear, but we can't see. Want to refresh and come back in. Let me see. All right, just let me let me see. Is anybody that? Yeah, I think we lost her. Let's wait until she comes back in. Um, yeah. Actually, that the whole thing with the Vulcan, that was pretty cool. I didn't know that. Like I knew of the Planck formula where there supposedly used to be a planet where the Kuiper belt is. That's what I thought you were referring to. But yeah, so let me see. All right, yes, can
Hello, can you hear
yay!
me?
Yes, yes, we can hear you and we can see you.
Did you all hear me talk about Vulcan, or would you like me to tell you about Vulcan again?
We heard you, but we didn't see you towards the end. I think
Okay.
we caught you. I think you went out when you were talking about um, the when Einstein said that it was the gravity, and then you guys realized that the gravity would explain it, and then obviously Vulcan fans were upset. Around there's when you kind of cut out.
Yeah, so the other part of that is just that it turns out there is no planet Vulcan in the solar system. But in the show Star Trek, right, they said that the character Spock came from a planet called Vulcan, right, this fictional planet. And they, in the Star Trek universe, put it on a real spot on a map, a celestial map. And they said, oh, it's around the star called 40 Eridani A. And it turns out we did actually years ago find an exoplanet around 40 Eridani A. So all the Star Trek fans were really excited and said, oh, hey, it's real. But actually, some of my colleagues found out last year that it's not real. That actually was just some issues with the data and the star seeming like there was a planet there, but actually there isn't. So we've gotten a lot of upset Star Trek fans with us in the last year saying we took away Vulcan. So Vulcan disappeared twice for everybody. So it's only living on in TV.
Okay. Perfect. Yeah. When she said that, and I don't know if Isabella was when she first started talking about that, I did not know about the Vulcan planet. That is super cool. But I had thought she was talking because there is I think based on the plan calculations, if I'm correct, obviously I'm not an astrophysicist, that they think there used to be a planet and where the astrobelt, where we have the asteroid belt. Is that I don't know if that's Isabella also something that you were or Josephina if you were thinking about that, but the Vulcan information was pretty awesome, I gotta say.
So I don't know if either of you were asking about it, but yeah, every few years someone comes up with some studies saying, "Oh, we looked at all this data and it suggests something." So there was a recent paper, and recent is probably a few years ago, right? That one of my colleagues said, if you look at all of the objects moving in the solar system, it's not really balanced. The only way you could balance it if you said there's this other planet, right? So some people called it Planet Nine, and they said like it's missing. But the deal with their expectations is that you're not going to see it again. And the whole thing about science is being able to make predictions that you can check. And so in this case, it just happens to not be possible to check, but then it makes it also much harder to believe because you don't know if it's real or not. So yeah, that's one of these things where the math looked like there's something off, but we're not sure why.
All right, so then who's next then? Do we want to throw it back to Mia and then Maya, or what do you want to do as far as the Josephina?
I have a couple of questions too. It reminds me about the Vulcan thing that I read that a lot of people at the time, the researchers actually had a plan to try to make proof of the planet that was by an eclipse. Since the planet was going to be so close to the Earth, to the sun, it would show up as a little dot on the sun. So that reminded me of the recent eclipse. But Maya, she's my vice president. She helped me basically like make the whole thing. She has a couple of questions too. So I think she might go ahead and say them.
So that's great.
Yeah, so my first question, I think you kind of touched on it a little bit before, but do you have any advice that you would give to a high school student interested in pursuing a career in astronomy or astrophysics right now?
A few pieces of advice. So one of them is astronomy is really cool. Like I think even people who don't like astronomy can't argue with that fact. Like you look at the stars, you look at eclipses, you see pretty pictures, and you think that's cool. And so I would say find as much to be excited about as you can, right? Whether that's reading things online, finding things on social media, going to museums and planetaria, but find things to get really excited about because if you go and study it all the time, like with any job, it doesn't seem as exciting anymore. But every astronomer I know has all of these memories and stories of things that they just loved. First discovering. And I think the first time you see something, it's kind of remarkable. So I would say just go and get as much of it as you can. And again, it's awesome that online you can get so many cool things. Like we put out a video a couple years ago that makes sonification. So there's just sounds like musical notes for each exoplanet, and you can watch it sort of play along the galaxy as we discovered them all in time, right? And that inspired various people I know to make their own musical instruments from astronomy data. But another piece of advice, and this might seem really weird, is to get really good at writing. So I can tell you when I was in high school, I hated writing essays. I was not very good at it. I found it like kind of painful. Like in math class, you get an answer, you're done. Like if it's right, cool. In, English, you have to analyze things, and in history, you have to write these essays. And I couldn't do it very well. But I have to tell you, like, if you become a scientist, and really in any job, but even in science, people think, oh, I don't need to worry about that. I just need to worry about, math and coding. But actually, being a really good writer is really important for other people being able to work with you, as well as just having the skill that allows you to just get further even on your own. So I would say to really practice your communication skills. And the last thing is if you're able to, try and, do a research project. Like I said, you can go to planethunters.org. I think you all are going to talk to Rob Zellum. Is that right? You can get involved with Exoplanet Watch, right? There's the micro observatory data on the computer that you can use without having to use your own telescope. I just bought my own first telescope for the first time this year, even though I'm an astronomer. And, my whole career up until now, I never had my own personal telescope. So you can sort of get started at any time. But I think doing a research project, whether it's on your own or, talking to somebody at a local astronomy club or a teacher or at a local university, those are really good ways to get involved. And I think once you've done a little bit of it, you can just go further if you want. So those are the three things, like lots of reading and getting excited, and exposure. The second thing is lots of writing. And the third is actually just get out and do it, with research.
All right, thank you. As the science ambassador for the exploration program at NASA, how do you approach making complex scientific ideas accessible to the general public?
Yeah, I really like talking to people. I find it's cool to learn about what other people are doing, and I want them to understand me. And I think when you learn all these technical terms in school, it's really easy to be like, I went through all this work to learn it, so I'm going to use all of these terms. But the thing is, if someone can't understand you, you can't really have a conversation, right? You're kind of talking at them. And so I find being able to use words that everybody understands, right? I don't think anybody ever minds being told something that they already know. They're like, oh, yeah, I feel good. I know that. I get that. Whereas if it's something that, oh, I don't understand that, that's kind of scary. And then they back away. So anything you can do to sort of build a bridge with them, I find analogies are really helpful. Like when I worked at the White House, so I spent a year after my PhD working at the White House. And in the White House, there's actually a meteorite. And this meteorite came down to Earth around the time we were getting ready to look at moon rocks. And so it landed in Allende in Mexico. And so it's called the Allende meteorite. And everyone loved using their microscopes and all of their equipment to study it because actually that meteorite is older than the Earth itself. It's part of what was used to form the solar system. It's what we call a chondritic meteorite. Except the thing is, it doesn't look very fancy or pretty. It's a black rock with white spots. So you're telling these people who are visiting the White House, they're like, oh, this is the White House. This is so fancy. Oh, you're going to show me something really amazing. And I go, that's a ugly rock. It's not shiny. It's not colorful. It's really boring. And you have to tell people like, oh, this is exciting. And they go, it's ugly. And so I would love to tell people that, if you go to bake a cake, right, and, you get the flour out and maybe you're a little bit messy like me and some gets on the counter, but you bake the cake, you put it in the oven, you take it out, you eat it. And maybe you don't feel like cleaning up. So you walk away and there's some like flour maybe like left in a circle around where the pan was on the counter. That rock, I would tell people like with those little white spots, those white spots were like the flour left over from building the planets, right? But it's from more than 4.5 billion years ago. So the fact that we can actually see what the planets were made of, so we don't have a time machine to go back, that's really cool. And like using an analogy like that with baking, where everyone sort of understands that, helped to get people more interested. Did people think the rock was suddenly beautiful? No. But, it's a way of communicating with them. So I think to your question, being able to communicate with others is super important. And it not only, helps them, but at least for me, it really makes it more exciting for me to be able to feel like I can I can hear about what you're thinking, and also I can feel like I'm making an impact, right? Whether it's teaching you something new or getting you to ask questions, it all is really rewarding.
All right, thank you. This next question is kind of a more personal one, but what do you think was one of the most rewarding moments in your role as a science communicator?
So, being a science communicator has all kinds of really weird moments. Like get to be on TV and things like that, which is kind of cool. But also like I was in a rap video earlier this year, right? All of you were thinking, what? Yeah, so I don't know if you've heard of the rapper named Logic. But Logic really likes Rubik's cubes and math, and he said he wanted to have scientists, like real scientists in his music video as like with his backup dance crew. So me and a colleague were asked to be in this music video. We wore like pink, astronaut jumpsuits. Um, and it was really interesting because we then did all of this work talking about the importance of science in a rap video, like and everything around it. So I don't know if that's necessarily the coolest moment, but it's definitely one of the most unexpected moments. I think for me, the coolest moments are when you see things click for someone and they can go off and use something in their own life. So during COVID, I'm not a doctor that can, save people's lives, but I do know how to program and do things on the computer. So I actually was a volunteer for the public health department here in Los Angeles. And so I helped work with all of the COVID data. And because of my work, we were actually able to figure out where did people need to get vaccinated and like where did you need to put the vaccination centers so that you could reach the most people and so they would actually come. And so I think for me that, that was some of it was analysis, but some of it was also doing the press conferences and trying to teach people and talk to them about the information they needed. And I think that was a really important form of science communication. So that's probably what I would say is the coolest thing, because I think at no other point in my career will I be able to say that I think I helped save someone's life.
Yeah, that is pretty interesting. Um, uh, how do you think, how do you see science communication evolving in the age of digital media and public engagement through platforms like Nova?
I am always excited for people to find ways to engage with science, right? It's something that, if you're already into social media and like I said, you see a cool space video, your first reaction is probably cool, not, oh, there's science hiding in there, right? I used to teach a class called Science and Cooking. And the reason I loved teaching that class is because everybody likes food in some ways. We might not all like the same food. We might not all like cooking food, but there is something about food that we all like. And so I think with all of these forms of new media, they appeal to people in different ways that, reach them and give them opportunities, right? Like you can right now respond to a NASA Universe Instagram post with a question. And one of my colleagues or I will respond to you, right? Like, I don't think it's ever been as easy to get a hold of one of us. And so I think social media presents lots of new opportunities. Of course, there's a lot of it and it can be kind of overwhelming, and how you manage that is difficult. But I think that's really cool because, especially like I work for the government, right? Like, we're the same people who give you booklets to tell you to do your taxes, right? And you can do your taxes on paper. That's like the most old-fashioned thing you could do in some ways. And so being able to, tag us or work in other ways, whether it's, a NASA handle or, a private entity, whether they're, public broadcasting or NPR or something else. I think that's all really cool. So it just gets more people involved and we can use all the help we can get. Did you have any other questions, Maya or Mia?
Are you done, Maya?
Yeah, that was the last question.
All right, so let's throw it back
Okay.
on to Mia
Yes.
to.
Throwing it back to me. Okay. So regarding the website that you previously mentioned, is Planet Hunters the same as Exoplanet Watch?
No, so Exoplanet Watch is helping actual astronomers basically make their measurements better. So we find all of these planets and we get really excited that we found it, but then we just kind of assume that everything is going to be the same. Like we don't check that, oh, the planet went around the star again. Oh, it went around again. But the thing is, different things can happen, right? Like you might actually realize that, oh, what I thought was the period or the orbital period of that planet isn't quite right. And so I go to look at it at this time and hey, it's not there. So Exoplanet Watch is actually getting really precise measurements on when do things happen regularly. And so the idea is that if you want to point like the James Webb Space Telescope at this point in space and say, I'm going to take, data about this exoplanet, you don't want to be really embarrassed to say, oh, I use this really expensive, fancy telescope to point at this planet and the planet's not there. So Exoplanet Watch is super useful to have people collecting more data to say, okay, these are what the real measurements are. And it's something that we don't always have time to do. Planet Hunters is a little bit different in that it takes just available data from various spacecraft and telescopes in the past, and it says, here is our data. See if you can find something we missed, right? So then you're actually finding new planets rather than saying, let's do a better job of what we've already found. So there are different ways to get involved. They're both citizen science projects, which, there are citizen science projects for everything, whether it's like studying birds or, different things during the eclipse. These are just the two that I think everybody in exoplanet astronomy gets excited about.
Okay, thank you. That was really cool.
Yeah.
Another question for those watching who don't know much about exoplanets, like myself. What is an exoplanet and how do you find these planets? And what is the process of them losing and forming their atmosphere work?
Yeah, so any planet that is outside of the solar system, we call it an extrasolar or for short exoplanet because it's not going around the sun, right? It's a little extra. Um, and so exoplanets are something that, you have to be able to look at stars and see what's changing because in the same way where the eclipse happens when the moon blocks out the light from the sun, right? So that's where you see the sunlight. Something is different. When we look at other stars, we can see a couple different things happening if there's an exoplanet in front of it. So one of them is if you actually can see the light of that star, just like you're looking at an eclipse, then if something passes in front of it, even if you can't see anything super high resolution, you can see that it got a little bit darker, right? Like just during an eclipse, it gets darker. And so what we do is we measure the light over and over again. And each time the light gets a little bit less bright, we call that a transit. So an eclipse is what we call it when the moon goes in front of the sun, and we say that's an eclipse. But when like Mercury or Venus goes in front of the sun, right, they don't block out the whole light. And so it's just a little dot. We say that's a transit, right? So there's the transit of Venus, the transit of Mercury. The next ones won't happen for quite a while. But when we see this of, the light getting dimmer from lots of stars, we say, oh, that's how we can find planets. And so of the like 6,000, well, the 5,700 planets that we found to date, um, the majority of them, probably like 3 or 4,000, have been found with this transit method, is saying like the light got dimmer. And it's not that it just got dimmer once, it's that it keeps getting dimmer repeatedly, right? Because you're like, okay, now I know that that's a reliable signature of a planet going in front of it. And you have to check that it isn't all kinds of other things, but people do that. Another way that you can actually see if there's a planet there is like we talked about earlier, you can actually just take pictures and say like, okay, if this is a star, do I see something moving around it? That's really hard to do. The star is really bright, the planet isn't. So we've only measured about 30 or so exoplanets like this. They tend to be really big, so they're a little easier to see and they tend to be really far from their star. So they're like Jupiter and they're cold. And so that's called direct imaging. And that's one of the things that we're working on doing a much better job of in the future because we want to take pictures. But the way the first exoplanets were found was something called the radial velocity method or the wobble technique. And what this is that when a planet is going around a star, it's not like the star just stands there and says, oh, yes, planet, please go around. I will stand here and wave. What happens is it's more like if the star is wearing a hula hoop, right? And so, the planet is going around this hula hoop, right? Sort of back and forth. But the star's got to keep that planet going in the hula hoop, right? Can't drop. So it's sort of like you wiggle your hips, right? The star moves back and forth based on where the planet is. And so you can actually look for that movement, and that's why it's called the wobble technique or radial velocity. You can see how a star is moving and say, oh, it's moving forward, it's moving backwards, it's sort of moving around. Oh, maybe there's a planet there. And they look for that repeated over and over again. So that's how the very first planets were found outside of our solar system. But well, not the very first, but some of the first. And there are other ways we can do this, again, by looking at how stars move on the sky, or how the light changes when something passes in front of them. But the main way we found exoplanets are transits and the wobble technique, and some with direct imaging.
Okay, thank you for explaining that. So you previously served at the White House Office of Science Technology. Could you tell us a little bit about your experience there?
Yeah. So I have to tell you, up until probably the time I worked at the White House, or just a couple years before, I didn't know that scientists worked at the White House. I thought, the president works at the White House and all kinds of people who maybe are from the military or who work in politics, but why would you need scientists? But as we can tell with climate change and COVID and all kinds of other things, science affects our lives in lots of different ways. And so they always need good people to come and join them. And so, because I mentioned that, I liked science because of maybe being able to help people with earthquakes, right? I found that even though I can't help people by predicting earthquakes, there are lots of ways where being able to tell people about science can be helpful. So some of the things that I worked on in the White House were about climate change, right? And, how do we collect the data we need? And what do we do with that data to help people make better decisions? So that they can be prepared for storms and they can be prepared for, it being hard to grow your crops. But also things like at the time I worked there, there was Ebola was raging in Africa. And that was the first time where people were talking about, yes, you want to treat people who have Ebola, but you also want to do research on it. Because the only time you can do research on Ebola is when you have these outbreaks. And so how do you teach, people of like, oh, when you have an ambulance coming to say, stop, stop, let the scientist in, like, let's do a little bit of science experimentation right now. Okay, go back to treating people, right? How do you work that out? Um, so there were all kinds of different topics. Like most of what I worked on had nothing to do with astrophysics. But I think that's the neat thing is that once you have enough of a background in how to read different academic literature and how to talk to people, you can understand what's going on. And then you can do all kinds of cool things. Like one of the things I worked on was how do we preserve the moon as a national park? And you might say, like, the moon is not a national park. The moon doesn't belong to America. But there were some things called UNESCO World Heritage Sites, right? That the UN protects various places. And so you might say, okay, yeah, the moon could be protected like that. But actually, the rules are if you want to protect something as a UNESCO World Heritage Site, it has to be protected by the country that says it should be. So you would have to first make part of the moon a national park, which isn't happening anytime soon because there are treaties and things that prevent parts of space belonging to anyone. So there were all kinds of really cool things I got to work on at the White House. Some were really important. Some were really minor, like I got to write speeches for the president. I got to meet the president and the first lady and, go to things like the White House Halloween party, which was pretty cool. So I actually was a hot Jupiter exoplanet for that year because the Secretary of State said, oh, I've never heard of a hot Jupiter. What's that? And I said, oh, it's a big puffy gas giant planet, but it's really close to its star. So it's hot and it evaporates. And he went, oh, that sounds weird. Okay. So I thought, all right, I'll be a hot Jupiter. So it's a whole different world, but it's one that I've had a lot of colleagues now work in more. And I think more people should know about different ways to get involved in public service because I've worked both at the White House and I've worked for, city government and county government. And I think there are lots of places that you can get involved as either an employee or a volunteer that are pretty cool.
So you said you met the president and the first lady. Which president did you meet? When did you serve at the White House? What
So
president?
I started there in 2016. So I met President Obama and Mrs. Obama, but I also worked there in 2017. So I also met President Trump. I'm in one of Vice President Pence's tweets, which is a weird thing that I never expected I would be in. But so yeah, so I've met them, but I haven't met. Well, actually, that's not true. President Biden said hi to me a couple weeks ago because I was at the UN because I also do work on sea level rise. Because of course, if you are studying the Earth from space, the oceans are a really good thing to study because in the middle of the ocean, there's nobody there to say what's going on. But a satellite can see everything. And so one of the things I like to work on, like I said, I like working on things that help people. Is sea level rise. And the UN had the opening of its General Assembly, so like the start of their new school year almost, last month. And so for the very first time ever, the UN had a special meeting about sea level rise. And so NASA sent some representatives there. So I was one of the people who was there. And so after President Biden gave his speech, he walked by and he said hi to me and we talked a little bit about space and then he went on. So yeah, that was pretty cool too. So I've met in total 4 presidents, but only 2 while I worked at the White House.
Okay, that's very interesting. Thank you. One final question for you, from me. What is your advice? Oh, sorry, wrong question. Sorry to put you on the spot, but do you have a quote or like a motivational phrase that has inspired and guided you down the journey of your career?
There's so many much more clever people who have said much more clever things than me. And so I always find it's easier to quote other people than to come up with something clever. So I'm glad you aren't making me come up with a clever quote. But one that I really like is, and I don't actually know who said it. There are various people who claim who it was, but I don't actually know. That nobody cares how much you know until they know how much you care. And I think that's really important because I think it's always this thing when you're in school of like, oh, do your best and like be on top. Um, and learn more. But I think, if you're not doing things for the right reasons and you're not sort of helping others, like I can't tell you how many times I've told people that the most important lesson I learned working at the White House and in Washington, D.C. is to just be a nice person and be a good person because it's like a small world. And if you're not very nice, people will remember that and it makes everything harder. But being a nice person gets you so much further. And I think not just being a nice person, but being, someone genuinely invested and caring, that makes all the difference. So, like, I do a lot of volunteering, but I also think that when people go around saying like, "Oh, she's really smart," I'm like, "Yeah, it doesn't matter, right? Like, what do you do with that?" So, that's a quote that I'll leave you with.
Okay, thank you so much for answering my questions. And I do think Miss G had a question for you about carbon footprint.
Okay.
Yes, so we're gonna sort of end with the topic of one of the STEM challenges down here for the from the Frost Museum. But before, Josephina, you want to say that your comment about the cookies and cream? What was it that
Oh,
the
the flour left over from baking.
yeah, well, go ahead.
Or that you mentioned that you did a program where you thought astronomy using like cooking, like
Oh, yeah, science and cooking. Yeah.
yeah, science cooking. That's basically what we're doing at my school because I didn't believe much like students at my school were gonna be interested in astronomy. The astronomy club was actually a thing my sophomore year, but it got discontinued. So I started it back up as Cookies and Cosmos. So it rhymed cookies and cream. We'll give like our members cookies each meeting so that they stay and they play our activity. And we're actually partnering up with the Frost Museum with like a climate change program that I think Ms. G can talk to me about.
Yes, so the two questions that I want to do sort of like the to tie it into the Frost Museum challenge is well the prompt they have is basically the carbon footprint in space, even though it's not a huge it's not a huge problem as opposed to what's with on Earth. What are the steps that NASA and the other maybe a space exploration companies are taking to try to reduce that. And then I want to maybe make it like a two-part question because you said something that was very interesting that when we're looking out into to try to find exoplanets, we actually want to see so sort of this carbon footprint, this sort of pollution in those exoplanets because that means that there's life on there. So I thought that was really interesting that in a way our pollution is also a blessing because it means we have life on this planet. But so that's a two-part question is what are we doing to reduce it? First of all, maybe explain what kind of carbon footprint is left by the space industry and then what are we doing to reduce it? And then how is that also a blessing in disguise, perhaps?
Yeah, going to space is really hard. Right? This is why we talk about the phrase rocket science. It's not rocket science. And part of that is like in the same way that I have to fill up the car with a tank of gas, right, to get somewhere, right? When I'm on empty, I can't get very far. Obviously, getting to space, like it's not that many miles up, but gravity is pulling you down. So you just need a lot of energy to escape gravity. And so to do that, right, you need to make these rockets that have lots of material in it that you can sort of have enough energy, right, to get out into space. So when people think about, what does it take to go to space? Part of it is just all of that material and energy and all that fuel that you need to get to space, and everything that takes. But when we think about, opportunities to reduce, the footprint of what goes into space, so we do have rockets now that have reusable boosters, right? Like the SpaceX rockets, right? You'll see that they come down and then you can reuse them a certain number of times. So like for Europa Clipper missions launch, those same booster rockets were used for the Psyche launch, which is a mission that went to an asteroid last year. Um, and they're gonna, I think it's what their sixth time being used. So that's one area where it was like, okay, we can't, obviously reuse gas, right? Because that gets used up. But and there's very specific kinds of fuels that people are using, but we can maybe like the container it comes in, we can reuse that. When people talk about the impact of space, people often worry about all of this orbital debris, right? Saying that in orbit, like you send spacecraft up, but you don't bring them back down and reuse them, right? They either burn up in the atmosphere and they continue to hang out. And that's one thing where we haven't really figured out what to do with it yet, right? We're still in our early stages of how to do things, right? In the same way that people used to all cook with like fire, right? Nowadays, you and I probably don't have like a campfire in our house. And that's good because all of the soot and things from cooking that would make us actually really sick, right? And this is why in parts of the world where people still use fires to cook, there's a lot more like issues with their lungs and environmental issues, right? Where we've sort of worked that out. So when it comes to space for like actually getting to space and what we do when we're there, we're still working it out. But the things that we do know how to do are, you have scientists who are traveling all over the country and the globe for meetings. How can we reduce that? So, we have a lot more hybrid meetings and we try and take a lot of steps of where we know how to do this, we can do something about it, right? Like we have less paper, we have just a lot of the things that you see in other parts of your life for dealing with carbon footprints. Um, but I think in terms of, reducing the carbon impact of space, we haven't worked anything out about the process at the level that I think would be most exciting to hear. But I will say one exciting thing that we do is use our satellites to measure greenhouse gases from space, right? And so one of the spacecraft that we helped with and its instruments actually can go and see where you have like methane or natural gas, right? Going up in to the atmosphere too much. And so you can find like where there's a leaky pipeline or where a landfill, right, hasn't been covered very well, or a dairy farm with cows where something is wrong in its pipes. And so when we see this, they call them methane plumes, we can tell them, hey, you have an issue, and they can actually fix that pipe. So that's not something about the impact of that satellite, but it is actually reducing the carbon impact of what's happening on Earth. So I think using satellites to do good work on Earth is pretty cool. To your other question, I'm trying to remember what I was going to tell you. Can you remind me of the second question, please?
So the yeah, so
Oh,
what
the pollution.
pollution? Yeah, to tie it back.
Yes, right. And so in the same way that you can do all kinds of clever things with satellites to study the Earth and try and help with climate change, and global warming, there's a lot of ways that you can look for signs of life on a planet, right? Like methane, for example, I just mentioned, will come with natural gas, like oil and fossil fuel burning. But if we find methane somewhere else, maybe it's from fossil fuels, maybe it's just from a volcano, right? And like life on the surface. So that is something we're interested in finding. But when you think about, well, let's just get creative of what are all the possible things. Like if we looked at our own Earth, what would you see in the atmosphere? So pollution is an example of like we haven't found a way to make, synthetic pollution, naturally from a forest or something like that. So that would probably come from people. So it's not that we're necessarily hoping to find pollution, right? But it's one of these things that if we did, we want to be prepared for all of these possibilities and think about, oh, that could be an interesting sign of something in the same way that people look for radio signals or these other things that we call them technosignatures, right? And they're evidence of technology that someone had radio and could communicate that way, as opposed to like methane and, oxygen and things that just come from people being alive and aren't necessarily signs of technology. So there's a lot to explore out there, and we're just trying to be ready for all of it.
Anybody has any questions and any additional questions that you want to, sort of any follow-up questions that you want to ask? It was great to have the clarification about the Planet Hunters and Expo and the Exoplanet Watch because I think I went in when to and now it sounds like I went into Planet Hunters and not Exoplanet Watch and I had gotten it confused as well myself. So I'm glad that But both in both cases, what you're saying is that citizen astronomers or even the students or anybody who wants to join can go in and help and be part of that. Um,
Absolutely.
Anybody else? Any more questions?
Yeah, I have a question. So, do you have any advice for the young women that wanna follow your footsteps and pursue careers in the science field?
Yeah, so I'd say don't follow anybody, like make your own path. So I'm doing one thing, and if you want to do the same thing as me, by all means, if you want to do something else, go for it. Like when I was going off and working at the White House and all of these other things, like I didn't know anybody who did stuff like that, right? And even my professors would say, like, I don't know if you want to do that. That's not what people do. And I say that because you'll get a lot of people who will make comments, whether they're, trying to be mean or they just don't know, other options, right? That'll make things seem like, oh, I don't know if that's an option. Like I'm somebody who, if I know something can be done, like if there's a math problem and I know it's got an answer, like I can keep trying until I find an answer. But if it's like, I don't know if this problem can be solved, then I get really worried and like I kind of give up a little more easily. And I think with too many things in life, right, especially like being the only woman in the room or the only person of color or something like that, right? Oftentimes it becomes easy to be like, oh, I think I'll just give up because I don't know if this can be done. And that's why I say just sort of blaze your own path and don't worry about people. That said, I think a couple of practical steps, right? Like one of them, a professor told me was, take as many classes and study as much as you possibly can because women like to feel really confident in something before they go forward, right? Like they always talk about how women apply for jobs when they meet all of the job criteria, and men will apply for a job when they meet some of the criteria because they're like, oh, I'll just give it a try. Whereas women are like, oh, I don't know if I know all of these things. And so one of the ways that you can help yourself deal with that possibility is to just be as prepared as possible because then you're like, I do know this act and I can go forward. So yeah, so one is to be prepared and lots of studying in classes if you think that will help. Yeah, ignore the haters. I think the other thing is just to get really comfortable of sort of building your own networks, right? So whether that's with other women, whether that's with mentors who are older, whether that's just with like a buddy system with a friend. I think making it so that you don't feel alone, even when you might be in various situations, I think makes a huge difference. And I think a lot of people I know find different ways to strategize about, finding a partner to do things with. But I think whether again it's in studying or something outside of that, it's always good to have company. And I highly recommend finding people in your life who can serve as mentors, right? Whether you're teachers, coaches, um, anyone else. Like for me, it's been people that it's not like someone ever comes up to you and says, can I be your mentor today? Like you kind of have to be a little bit more active in finding that, but that makes a big difference. So those are two things that I think are helpful.
Great. Thank you so much.
You're welcome.
I think I'd like to do a follow up on that, and then we can wrap it up. I think we've stolen an hour and 10 minutes of your day, but we are so grateful for that. And you hear, I'm very much and that's why I'm doing this, even though I'm in the arts. I've always been sort of like a science nerd myself, and I one of my things that I love is to promote the concept of STEM among women. So my question to you, and I loved the answer to that previous question that Mia said, but how is it now as opposed to, let's say, because I remember when I was growing up, it's a very different way it is now. So much, so many more girls in STEM. How is it? What are you seeing as far as the participation of women in STEM? The future of that is there growth, is there, how is it now pretty much?
I think everything, when we look around, we're like, oh, we've made progress, but we could still go a lot further, right? And I think that's true in the sciences for sure. I mean, you'll find a lot of women tend to prefer the life sciences over the physical sciences, right? So you'll see more women in biology than in physics. And I think that's totally fine. I think part of it is preference and part of it is like, oh, there are already people there. That's like a little more comfortable. Um, and so I would say, I am still often the only woman or one of a few women in the room. I am often the only person of color. And I think it's easy to say, oh, things are so bad right now, and I feel really discouraged. Like people ask me, where did you learn to speak English? And I go, like down the road, it's my native language. I'm glad I speak it well. Thanks. Um, and people have all kinds of ideas that it's really easy to be like, wow, I can't believe another scientist at NASA asked me where I learned to speak English. Like, I'm so upset. But, like that doesn't really get you anywhere, right? Just going and being awesome and showing people what you can do is, I think, a lot more effective. And so, as you're looking around and saying, like, oh, this is kind of disappointing, like, go and be that person, right? And yeah, it's kind of isolating. And that's why I said, like, find friends, friends help. This is also why, like, be a nice person. It's a very small world. You'll need everybody's support and be there to help them. But you can always do more. And I always like to tell people that it isn't just about, like, I want to see more women in STEM in the future. Cause, like, if you don't want to do STEM, don't do STEM. Do something you like, right? And just feel able to pursue whatever it is you like. I just happen to think, STEM is awesome, but that's just me. And I want to just applaud all of you for what you're doing with Astronomy Club and with journalism and getting really involved outside of, the sort of bare minimums that you have to do, because I think when you make all these connections, it impacts the community and people also feel inspired, right? That they might have been feeling sort of like, oh, I don't know about this. And it's like, oh, here's a pathway. So I just want to applaud all of you for what you're doing. I think that's really cool.
Thank you. Thank you. And I want to thank all the girls from and the journalists. We had another one of our journalists, because they take care of the special packages. It was sort of like a team effort that, but he had practice, I believe. So and his practice ended right before, so it was like he just wasn't able to make it. But I am so grateful for the astronomy club to be able to make it as well. The sponsor also wanted to be present for the astronomy club, and he wasn't able to make it because he's actually teaching because he teaches at another university right now, or another college. But thank you, Isabella. Thank you, Maya, Josefina, and Mia, and of course, Dr. Tripathi. Did I say it correctly? And so, I'm super, super grateful that you have, given us your time, and it's been very. I've learned stuff. I mean, I thought I had. I mean, I'm not an astrophysicist, but I thought I had read enough. The guy, I can understand the topic, I can get along, but then the Vulcan thing was threw me for the loop. I was like, ah, I hadn't heard that story, so I thought, so I definitely learned something new, and I love it. And hopefully, we can edit this and put it in the on Monday, and and sort of have this, and with Rob's live talk be able to inspire maybe a new generation of people to just get a little bit more interested in the weird and strange world that is the space is and the astronomy is. So anybody wants to say anything else? Do you want to say thank you? Want to say goodbye? Do you want, anybody else?
I just want to say thank you, doctor, for taking time out of your day and speaking to us. We all greatly appreciate it. By the kind, like we appreciate it. We really do. And I hope you have a great rest of your day. And again, thank you.
You're very welcome. And thank all of you again for putting this together. I hope you'll share with me what you produce if you're able to. That's always fun to see. And I think Steve is going to send you a package of goodies. But if you have any issues with that, let me know. And Rob and I can help send you more fun things.
Yeah,
Um,
we received a whole bunch of posters and stickers.
okay.
They did an unboxing video which has not been posted yet because our program, the actually CRTB program, is just kind of like astronomy. We just this is the new year. We're building it again. So we just did we opened the Instagram, so we haven't had the first post. So the unboxing was going to be the first post, but hopefully we can celebrate, and I'll tag all you guys, and I'll send you guys links to everything. So. Josephina, do you want to say anything?
Just thank you for letting us know about all of these resources. I'll definitely be doing a little activity in class about the planet hunters because I believe a lot of our students will be interested in that. And thank you for letting us know about everything.
You're very welcome. And if you want other activities, I can suggest ones like, like jelly bean guessing games. We do one like that, but it's a jar where the number of beads, we use beads because NASA doesn't let us buy jelly beans. But the number of beads in the jar is the number of exoplanets there are, and getting people to guess like not only how many, but like what year did we know of that many? So there are different things you can do. So I'm always happy to be a resource for all of you, even after today. But yeah, thanks again for doing this. I think it's awesome. And I hope you can
All
all get
right.
some rest now.
One more quick question. Why does
Yeah.
it not say that you guys buy jelly beans?
Um, Again, it's like your tax dollars at work. They want to make sure we're being really responsible. So we're allowed to buy beads because like I'm not gonna like steal beads. But jelly beans are something that, maybe someone gets hungry and eats a couple. So that's just
Yeah.
the rule.
Makes sense. Makes sense.
Interesting. Thank you. Thank you so much. Well, I think we can, unless anybody has any follow-up questions, thank you once again, and we're going to go ahead and try and get this edited. I guess Mia will talk about it in when we to see who is Eddie going to be doing that, or it's going to be Ryan and all that good stuff. And obviously, you guys have, by sheer error on my part, you have Dr. Tripathi's email. But do please be responsible if you're going to send her any questions. Ask me, you see me, and all that good stuff. But yes, thank you so much. And I did hate to see the interview end because it's been really, really entertaining, and also I love learning stuff about space, so I've enjoyed it thoroughly. But we can't keep you forever. Thank you.
Everyone, go and have a good rest of your day. I'll talk to you later.
You.
Thanks so much
Bye,
for having me.
guys. Have a great evening.